So there is some little formula, like if we interchange two rows, then determinant will change the sign. For example, I took the fourth row in the first row, and I took the first row to the into the fourth row. Okay, so I changed the first and the fourth row. Then our sign will then we have to take a minus here. Okay, that means our sign will get changed because we changed on row. Okay, guys. So if we change row, then our determinant sign will change. Here we interchanged R1 with R4. R4. Okay. That's why we got a minus sign here. Okay. And then they had some row operation, and after doing all of this row operation, we have ended up with a solution that is minus 19. Okay, because if all the value below the main diagonal is 0, then the solution will be the multiplication of main diagonal. Okay, let me tell you again. So here, this is our main diagonal, right? So how do we find the main diagonal? You just draw a angular line here. Okay, so I think you will get the main diagonal this way. So all this value below this main diagonal is 0. That means if we multiply the entries of main diagonal, that means 1 multiply 1 multiply 1 multiply minus 19. That means total value will be minus 19. Okay. So for example, here we have another matrix. So we do this two operation, and then we get two rows. Oh, sorry, then we get two column as identical, right? This two column is all the value is 1. So we can say that the result will be 0. And here we are trying to make this 2 minus 3. Okay, we are trying to make 3 4 1 2. Okay, so we are trying to make the first row, all the value, we are trying to make all the value of the first row as same. Okay, so we just add this number, like we just add 1 with 2, and then 2 with 3, and then 3 with 4. That means 2 plus 1 3, 3 plus 3 6, 6 plus 4 10. Okay, and then we substitute the value to the first row. That means all the value of the first row, it will be 10, right? Okay, and I don't change any other rows because I only did the row operation at the first row. That's why I didn't change any other row. So then we can we can factor out 10. We can factor out 10 from the first row. Okay, so we only get on, right? We get on the first row. Then if we do this kind of row operation, they are pretty simple. Okay, just according to your need, you need to multiply the, for example, here is 2. So if you multiply 2 with the first row, then you can easily subtract this 2 row, right? And then you get 0 here. Again, for the third row, you multiply 3 with the first row, and then you subtract the first row from the third row. Okay, then you get another 0 here. Okay, so this is simple row operation. Okay, guys, so you get some kind of on here, on the first row, and down here you will get a lot of 0. So little by little, your all the entries below the main diagonal, it will become 0. Then to find the solution, you can just multiply the numbers of main diagonal. So 1 multiply 1 is 1, multiply 4 is 4, 4 multiply minus 4 is minus 8. So sorry, 4 multiply minus 4 is minus 16. So minus 16 multiply this minus 10, it will become 160. Okay, so this way we can calculate, we can find the solution of our matrix. And adjoint, or it is called, it is also written as this way, A star. Okay, so any matrix, if we multiply that matrix with the adjoint matrix, then we can get adjoint matrix, and also the identity matrix. Or we can say, if we multiply a matrix with its inverse matrix, so we can get identity matrix. Or inverse matrix is the adjoint matrix divided by the what is this, the determinant. Okay, this is called determinant, I mean modulus A. So we can get the inverse matrix if we just divide the, if we divide this way, like if we divide the adjoint matrix, if we divide the determinant. Okay, if we divide the determinant with adjoint matrix, then we get the inverse matrix. Okay, this is adjoint matrix, this is our determinant, and this is our inverse matrix. So that's all for today. I think I have covered most of the parts that Lausi discussed in the classroom. So
Yes.
stopping the recording.
Yeah.